Today, we're talking to Roland from OnLogic and Said from ZEDEDA about the ways in which edge computing is pivotal to the advancement of modern technology and Roland and Said's most impactful leadership lessons. Thanks to OnLogic for sponsoring this episode. Go to onlogic.com to learn what they can do for you at the edge. You're listening to Joel Beasley, Modern CTO.
Hello, guys. How are you?
Hey, Joel.
Where are you guys calling in from today?
It's Silicon Valley.
Silicon Valley. And what about you, Roland?
That sounds much more fancy than where I'm at. We're in Vermont.
Nice. But you're both from the Netherlands, right?
Correct. Yeah.
Were you friends over in the Netherlands first, or did you meet later?
No, we met really only a couple of years ago. Said actually reached out to me through LinkedIn. And we have a number of people, common connections and things like that, but we hadn't met each other before. So it was a new connection. And he said, hey, we're working on this software and is there an opportunity to work together here? So I said, let's talk.
So you guys met through LinkedIn. What was the reason for doing business together? How do you interface with each other?
So we've been building an operating system for edge computing. And some of our early customers, basically told us about OnLogic. So we run on any hardware, but they were, telling us how happy they were with the OnLogic hardware. And, they were using our software on the OnLogic hardware. So then, based on that, I started doing a little bit of research on OnLogic, realized the company color was orange too. So then realized Roland was Dutch. So I just reached out and typical Dutch said, hey, I think we have some joint customers. I think we could, do more together, and happy that Roland responded to that.
So tell me more about what it is you actually do together.
Really, if you think about it, we make hardware and ZEDEDA makes cloud orchestration software and does a lot more than that. But we really want to focus on hardware, but our customers tend to want to focus on buying a whole solution. And this is where partnerships really come in, right? So it gives us the ability to offer the full solution without having to do it all ourselves. And that's really what this is.
Very cool. So you're the hardware component. And then Said, you're the software component.
Yeah. We always talk about it as a peanut butter and jelly. Each of them are separately really good, but you put them together, they're extra good.
Yeah. And that's what I want. I want to buy the sandwich. I don't want to buy everything and piece it together, right?
Yes, that's right. Yeah, and that's one of the reasons we decided to work together. We obviously have been focusing on this new emerging market called edge computing, from a hardware and both the software point of view. And as we talk to a lot of these customers, in particular large, enterprises, they definitely would love for vendors to work together and simplify the experience. And that led to the partnership between the two companies.
And I want to get into that. I want to get into exactly what you guys are doing with edge deployments and nerd out a little bit. But before we jump into those details, I was hoping a lot of the people that listen to the show, they'll listen for tips and advice on how to become a better leader. And so what I like to ask for each of you is, what are you currently learning right now as a leader?
Wow, deep question. I think you're always learning as a leader. I've actually recently gotten more involved in the day-to-day operations of our engineering team. And what I found is that setting expectations is extremely important, right? And people can't. It's a very basic situation, but people can live up to expectations if those expectations aren't voiced, and I think that's really critically important, because once you do, you get a much better rapport with people, and everybody's on the same page. It's so basic, but it's something that I'm finding that not all managers do, and then you get back into a team, and you're seeing that really has kind of caused some morale issues and things like that. So that's what it's kind of the flavor of the day for me right now, but it's actually a very important piece of what I'm doing right now.
Do you have some tactics, how it actually expresses itself? How do you actually do that?
Yeah, it's a good question. So we have from the start of the business, we've always really focused on company culture and really early on set our core values and how we operate, right? And one of those core values, a couple of those core values are open and fair, and those really go hand in hand. But open is all really about open feedback and giving people constant feedback, and both ways too, right? Super important. So that's a piece where if you have that sort of baseline in place, it becomes also so much easier to give people the feedback, set those expectations, and really give that ongoing feedback cycle.
Yeah, I find myself with setting expectations, the thing I end up doing the most is just being simple and repetitive with what the expectation is. Because you'll say it once, and as the leader, you're like, it's been said. Move on. So it's been said, and then it's like taking a shower. You have to do it, all the time.
So true, right? We have a management coach that we work with, and he always tells everyone in the management team, you got to repeat something 7 times for it to really stick. And it's important to really keep thinking about that, because you do think, I've said this to someone, why don't they pick this up, right? But it's all about repeat. And not necessarily in the exact same way, but in different ways, and use examples and situations to talk about these things.
That's why I tell everybody the fastest path to become a better leader is to have kids. Yeah, you'll repeat yourself a lot. You'll learn a lot. I've got 3 kids under the age of 7, and man, has that helped my patience, right?
Especially patience.
Yes. Right. My kids are 18 and 20, and at this point, I don't think they take much feedback at all anymore. So
that's a good thing, though. You don't want them taking too much feedback at that age. You should have trained your AI model correctly, and it should be operating in the wild.
Exactly. They're out there doing their own thing. Yeah.
Saeed, what are you learning right now as a leader?
Well, I would say definitely to your point on communications, it's all, it never stops. You can always improve and get better in communications, like, setting expectations, communicating, following up. ZEDEDA itself, we've gone through a lot of growth last year. About 40% of the company has been on board now less than 12 months. So we're dealing with an influx of a lot of new people, also a lot of different locations in the world. We're quite an international organization. We just opened up an office in Abu Dhabi. We have offices in India and Europe and other places in the world. So for us, it's also been like not only communications, but how do we make sure the new employees get on board as soon as possible, feel part of the team? How do you balance all the good new things that can bring to the culture, but balancing it also with, staying close to some of the core values and what is important for us as a company? And I think, it's interesting around the communications, because sometimes you kind of have to remind the people that have been on board for a little longer that they can't expect the new people to know it all right away. And it's not always clear. So that patience is, I think, important. We have to, especially with the people that have been on board a little longer, explain them there's more responsibility to them to help their new colleagues to be successful here and get them up to speed and answer questions, even how basic they may be, and then figuring out how to scale that as we continue to grow the company.
Okay, so help me with this. You said you've grown 40% in the past year or so. So let's say you could go back, rewind a year, from everything that you've learned with that growth and the mistakes and of integrating people into your culture. What's the one piece of advice if you could have an all hands meeting, go back in time to 1 year before you started this rapid growth, what would you tell your people?
Well, I told them that we were going to grow and we're going to add a lot of people, and that it would put stress and everything else in the organization. But probably I should have said it 7 times.
Yes.
That's probably it. Just keep repeating it. And because, sometimes I go I'm not surprised, and that's part of it. But it's been not as rocky. It's just something you have to keep in mind. And, sometimes, unfortunately, people don't get their honeymoon or their period to get up to speed. You have to just throw them in the deep and say, listen, I need you to go and, solve this or work with this customer or accelerate that. So that is all part, I think, also of the startup experience.
Very cool. Good answers. You guys are some strong leaders. I like that. Thank you so much. Yeah. Let's talk about the reality of edge deployments, right? So let's just start real simple. What does it look like in 2025 to get it right at the edge?
So we started on focusing on edge computing before the industry was called that. So the company started back in 2016, 17. And we saw sort of 2 trends happening that would create this new category of edge computing. One was that the cloud computing model was going to win. Not because of the utility of cloud, the rent of resources and all that, but actually it was changing the way how we were building applications in cloud native software development and everything else. So our view was pretty clear then already. It's anybody that will be building an application moving forward that's not going to run on a phone or PC, will be building it in cloud native ways. The other trend we saw was Internet of Things, IoT, more and more things getting connected to the network. These things generate data. You need software to analyze and process that data. And so for us, it was kind of okay, there's going to be 2 ways how this is going to pan out. Either you upload all the data to the cloud, where that application makes sense of the data, with more and more AI, by the way, infused in it. Or do we take this application and push it to the edge of the network, and we'll be running these cloud native applications in high number remote distributed locations and things like that. So we said that's what's going to happen. You can't upload all the data. It's just too impossible, too much data. Networks are not built for uploading data. So instead, people will start putting edge compute hardware like Roland's OnLogic systems in more and more distributed locations. And then they're going to want to run these cloud native apps on that. And we basically built an orchestration solution with an operating system to give customers the exact same experience they get from the cloud guys. So APIs in the cloud and that kind of self-service, instant experience. But instead of these apps running in a data center, they run on all of these distributed edge environments. I'd say in the early days, edge computing was more a hype than reality. There was a lot of companies talking about edge computing. Frankly, if you were not a cloud company, you were calling yourself an edge company in those days. But I think what we've seen now is that large enterprises now have started to adopt it more and more at scale. And there's sort of a couple things that I think matter a lot for them. I think number one, what matters a lot is sort of the flexibility, because every edge compute deployment is unique. You're solving a specific business problem. It's not all, SAP on VMware everywhere. It's like, you're running on a vessel in the middle of the ocean. We have customers doing that, and they're connecting to containers on the vessel, and they're trying to get data out of the cargo. Or you're deploying in oil and gas sites, and you're part of drilling, or you're deploying in solar farms, and you're running unmanned solar farms all around the world. So they're all very unique deployments. The second thing we saw was security was being a big deal, like zero trust security and things like that, which is one of the things actually that with OnLogic, we've built a really nice integrated solution there around zero trust security. And the last thing is just being able to scale. I mean, a lot of these deployments start small, a few hundred nodes, but we have one customer that has deployed over 15,000 edge compute nodes in like dealers and service centers that are running an application stack that's used to diagnose cars when they get dropped off for service. So that's a massive deployment, and everyone was running Kubernetes and everything else. So how do you scale with the enterprise has been a big part of it.
Wow, 15,000 units they have out there?
Yeah, pretty much around the world in like dealers and service centers for a very large automotive brand.
And what is edge washing?
Well, edge washing is, I think, using edge computing to take an old, maybe more mature market. Let's talk about data centers as an example, and trying to call that edge computing, right? And to me, people that run applications in data centers, they're thinking about how to move them to the cloud. What we do with edge computing is about how we take applications that are in the cloud and push them out to the edge. So I think we're kind of more after instead of before cloud.
Got it.
We had not too long ago a meeting with a company who does somewhat in our space, and there was a whole discussion around near edge and far edge, and I go like, it really doesn't matter, right? It's not really why they may try to make a distinction there, but I think there's sort of they were going after. What they were looking at is this near edge would be kind of like servers that you have on-premise, and far edge being the devices throughout. But it's all a matter of definition. It's like Said was saying, years ago it was embedded computing, then it became IoT. Intel then coined the word fog computing, right? It was cloud computing and fog computing, and that was like a big thing, like the next big thing for computing. Well, that went nowhere clearly, and then it became edge computing. So it all kind of is really newer names for the same thing over time. Although having said that, the technology does progress, and the software really ties it all back together. And I think that's where what's really interesting is that the combination of cloud and edge combined is where you get the value out of. And Said always says you can't have edge without the cloud, right? And that makes a lot of sense.
So other than edge, is there any other terms that they're doing that with right now?
I mean, AI, right? Like AI is edge everywhere. AI. Yeah, edge AI.
Edge AI. Yeah. There we go. Cloud and edge AI. That should be the most popular episode we ever do.
Yes, right? That's right. Combine it all.
I would say that at least the customers that we work with, they don't really call it edge computing. I don't think they wake up in the morning and say, hey, I'm going to go and do some edge computing. I think it starts really with actual business problems, like they're trying to really improve their operations, or they're trying to introduce new capabilities in their business that makes them more competitive or generate new revenues. I mean, those are usually the drivers. And then as part of it, a piece of software needs to run outside of the cloud. It just can't run all in the cloud, right? And then that sort of then drives, okay, well, we're going to need hardware, we're going to need orchestration servers, we're going to need all these other things in addition. That's typically what we see with our customers. And I think that's why over-rotating on marketing for edge computing, I think it's fine. It explains what you do, but I think it's more importantly to talk actually about what customers are doing with edge computing and how it's solving their issues. We see that being a lot more valuable.
Yeah, let's talk about that. And I know you guys sent over a few examples. One of them I thought was really interesting is AI computer vision in rail operations. Rail like as in trains?
Yeah, so there's obviously a couple of years ago, as you may know, there were a couple of really large disasters like East Palestine and others where trains derailed. They were often caused by mechanical defects on the train, like, some part of the train had a mechanical defect. They didn't know it. I don't know if you know nowadays, but a freight train can be 2 to 3 miles long, which means the engineer in the front has no idea what's happening 2 or 3 miles behind them. So actually there's been a lot of pressure also from legislation to improve the things called defect detection system. They're actually called railway side defect detection systems, which basically are stations on the railway track, where as the train passes, they use cameras and other sensors to see if the train is mechanically okay. So for instance, if a wheel disintegrates, it starts generating lots of sparks before it completely falls apart. So a camera can detect that, say, hey, I'm seeing this wheel not turning normally, but it's kind of being slid over the track and sparks coming off, and can signal to the engineer through software and communications to stop the train because it may have, an imminent failure, right? So that's an example. And we've been working together OnLogic and ZEDEDA with a couple of the largest, tier 1 railway companies in the US to improve their railway defect detection systems. And that uses edge computing.
Okay, so let's talk more about that. So Roland, I think it's pretty obvious that wherever they have these stations, that's where your computers are going to sit, your hardware is going to sit. Is that correct?
Right. And I think, and then combine it with some sensors, cameras, those kinds of things, right? Usually these locations also need 5G or 4G connectivity because there's frequently no internet. There's, typically barely power in those locations, right? And power can also be an issue in some of those. And really where ZEDEDA comes in this situation is it's very similar to sort of how you would cloud provision an application in the cloud. Now, instead of having to manage each and every one of these computers individually, what happens is as soon as you turn the unit on, it connects to the ZEDEDA cloud orchestration platform or edge orchestration platform. And from there on, you can then manage each and every one of those computers. You can do, double check that the security is exactly the way it's supposed to be. You can do remote updates. You can manage all the data that's on there, things like that. You can add and deinstall applications as needed, those kinds of things.
And then where does Saeed's technology sit?
So basically, first of all, the building hardware that sits in the middle of, high temperature, low temperature for prolonged periods of time and is reliable is not easy. So let's start with that. And that's what we love also what OnLogic has been doing in terms of kind of the way the systems are built and the practice behind that. So you need hardware that meets the requirements first. Then our software runs on top of it. And what we basically built is we took Linux, but we adapted it for edge computing, just like Android took Linux and adapted it for mobile computing. So think about it that way. Like we made it very easy to run applications on OnLogic hardware, things like secure and everything else. And we basically built an API-driven operating system. And then we sell in addition a SaaS service that gives customers that cloud experience where they log into a SaaS interface, and then through that they can deploy, update, monitor the entire stack that runs on all of these locations. Because it's not about only the first install. The first install is obviously the hardest, get that system up and running. But then you want to continue to improve the software stack on these systems. This is the difference, I think, between embedded computing, where you kind of build software and you deploy it and you kind of only change the software when you change the hardware. But what we're doing with edge computing is we actually unlock more and more new capabilities and new features and innovations on top of that software stack on the same hardware over a period of time. So for instance, in the railway, maybe you add another sensor which improves the ability to detect certain defects, or you add a camera and you can now monitor a railway crossing if this station happens to be next to a railway crossing. So you can add that in addition to monitoring the train. You can monitor also those type of things. So more and more sensory information requires more and more software, and you want to be able to update that dynamically, just like you're updating software in the cloud.
And then as far as like the actual technology, so my background's software engineering. So are you doing like the infrastructure and orchestration, or are you actually writing the software that's processing the images and data?
No, we basically do the infrastructure layer. So think of us like, I guess the best example I can give is think about what VMware did in a data center, where they gave you, the software-defined data center with the hypervisor and the management and everything else. But we did that for Edge. And the big difference is it runs on a high variety of different hardware because every deployment is unique because of the environmentals, the amount of data you're trying to process, the type of sensors that are connected. It all drives very diverse hardware. Which again, the partnership with OnLogic has been great because OnLogic has been able to really build a modular architecture that can rapidly adapt to all of these different deployment targets. And then unlike VMware, which I think was more an IT tool, we're thinking of ourselves more as a cloud-like tool. So kind of giving more things like APIs in the cloud, CI/CD, use Terraform, all the modern cloud tools that people use to manage infrastructure in the cloud. We extend that now to the edge.
Oh, that's really cool. The most frustrating thing for me, Josh, is when I call support and I can't understand them.
Yeah, man, I hate that.
That's why I like US Cloud. Not only is it better, faster support, but all the engineers are US-based engineers. And it's also a lot cheaper. 94% of US Cloud's clients report saving a third or more when switching from Microsoft Unified Support to US Cloud. So now you'll just have to figure out what to do with all that extra money. If it were me, I'm responsible, so I'd reallocate the money to improve my team. Josh, what would you do?
I'd probably just buy more guitars.
More guitars. Visit uscloud.com to book a call and figure out how much your team can save. I've got to ask. I almost cringe at asking, but are you using like AI or LLMs or GPTs inside your orchestration?
We are introducing more and more AI, but we're not trying to do it because it's a buzzword. We're trying to really do it as part of improving the customer experience. One of our mottos is customer first. So we really want to help customers with that. So one of the things we're doing, for instance, is we've built an analytics engine where if we see a lot of events happening at the same time, we can correlate those. Like let's say you have a piece of hardware and it's rebooting our system and it's rebooting 3 times within 3 hours, and it never normally does that. We then identify it as an anomaly and then can bring that up to our customers and say, hey, we've had these reboots. We're seeing this kind of happening more widespread since the software update or whatever. There may be a problem in the software or something else we have to investigate further. So that's how we think about it. AI more from our product is like improving the experience. We put all documentation in AI on an agent, so you don't have to like go through the table of contents and find what you just tell us what you want. I want to install the OS on the hardware. Here's the description how to do that. So we're trying to use AI in an intelligent way. Now, many of our customers use us to deploy AI at the edge. And so Roland and myself, we've been really talking a lot about like, how do we see this evolution and how do we deliver more and more accelerated compute that makes it easier to like run more complex models with vision and other things, including Gen AI. We have customers that are trying to replace the entire HMI, the human machine interface of a machine, with a voice Gen AI interface. So you can talk to the machine just like Star Trek. Those are pretty cool projects. They're early, but I think they're kind of starting to push the boundaries of the possibilities here.
And then at the same time, that technology is just advancing at an incredible speed. Like I can't even keep up with all the stuff on X. Like every week there's some massive, there's this new way of doing things. And I think one just came out, and Josh can correct me, but it's like called MCM or something. But basically the idea was that it was this framework for connecting data sets. Have you looked at that, Saeed?
Yeah, it's the MCP. It's a way for agents to talk to each other, which is sort of pushing this agentic AI thinking. It's really exciting. And I think, again, we will see more and more AI agents being deployed all across the edge and the cloud. It won't all run in the cloud, won't all run in the edge. So, but yeah, we're in a very interesting time where there's so much great innovation happening and people building off each other's ideas. It's really a great time in tech, that's for sure.
And then I want to know what you're doing with the predictive maintenance and solar tracking.
So a lot of the time, right? So in our field, customers need a device that's in a very remote application. Solar tracking is one of those examples, but same for any sort of energy environment, whether it's oil and gas or wind or solar, all those areas. You're talking about very remote deployments, but also very difficult environments. So for us, that's where we have these systems that can withstand extreme temperatures, shock, vibration, those kinds of things. And more are we adding an AI accelerator or a GPU or an NPU to those systems So then, because more and more software, AI software requires more and more powerful hardware really at this point. So that's kind of what we're working on. And from there on, it's that through the AI software that's loaded on there, you can actually then do all these predictive maintenance kind of things. You can, for solar farms, it's a great example, right? You want to make sure that every panel is functioning as expected. And if one panel is out, you can actually detect that based on performance, right? You can compare the performance of one string of panels to another string of panels, and all of a sudden you see a difference, you see a delta happening, and this is where AI automatically picks out, like, here's where a problem is, and pinpoints it and sends data back to a central location, and a technician can come out and come fix it.
That's pretty cool. There's a lot of really interesting use cases.
Yeah, especially when the cost of sending somebody on site is higher than the actual cost of the repairs or replacement.
Mm-hmm.
So with predictive, you can actually start using failure patterns that happen before whatever panel fails. We had a customer in wind farms, same problem. Wind farms are even harder because you need a crane to go all the way up there.
Mm-hmm.
So they were really trying to say, like, okay, if we can predict failures, if we know that like a solar panel or wind farm or whatever the asset is starts exhibiting these type of things that we can detect with a sensor, and we can go in and fix 3 or 4 panels at the same time, or 3 or 4 farm wind turbines at the same time, we significantly reduce our repair costs. So, and number 2 is reduce our downtime, right? And those are the 2 things that improve ultimately your bottom line, right? So that's kind of what we see a lot of people trying to use predictive analytics for, and predictive AI.
Yeah, I can believe that with the cost. I talked with somebody a while back, and they were saying that they would spend like $100,000 to have like a part for their mining vehicle. Like, like it was in Australia and they mined like ore or something out of the earth, but this like one part broke, and it was like a 10 or 20 grand part, but they would have to spend like $100,000 to like helicopter it in within 24 hours. Cause the amount of money they would lose from that thing not mining in the earth's ore was just so staggering. And I was like, wow, that's crazy. I never think about that. Yeah.
Again, mining is an example where our computers are used a lot too, right? You end up in these really, really tricky environments, a lot of dust, a lot of shock vibration, those kinds of things, and a lot of and a lot of predictive maintenance on the machinery. Absolutely, it's that whole piece.
Fusing the edge and the cloud, right? So where do they exactly come together? Is it something we want to do? Is it something that's happening?
Yeah, I mean, I don't think you can do one without the other. And frankly, if people want to do edge without cloud or not doing cloud, it usually tells me they want to kind of stay in the old world. They're not really ready for the new world. And the reason is because, you still need to store data somewhere. Like, and the edge is not the best place to store your data. You don't want to have a lot of little, storage places of your data. You want to have ideally a central place where all your data gets stored, your historical data. You also need that data if you're doing things like training, like training models. You need lots of amounts of data. So ideally centralized. So I think of it as a pipeline. I think of it like, okay, you got a sensor. It generates, let's say, a video feed. You could upload that video feed to the cloud and analyze that video feed to detect what's happening, detect objects or whatever, which is quite costly, especially if you have a lot of video feeds. Or you put, edge servers, edge computers locally, and you process the video feed there. And then what the AI model detects in the video feed, you send still that to the cloud. So you're part of a data pipeline. And those you store in a nice database. You say, I saw object 1 at this time in this camera, object 2 at that time and the other camera. And that becomes sort of your place where you can visualize that information, where you can share that information with, within your organization. You can use that to train on that information. That makes a lot of sense. But, but you still need edge. So I think of it as a data reduction kind of pipeline where the majority of the data gets processed at the edge, and then the useful bits get sent back to the cloud and stored there.
And I've got to ask, what does the name of your company mean? ZEDEDA. Like, what does that mean?
Yeah, it's a great question. So, as you kind of alluded earlier, both Roland and I are from the Netherlands. I was born and raised in the Netherlands, but my family is actually Moroccan. So my roots are Moroccan. And ZEDEDA is a Moroccan word. It means new or innovative. And then we chose the orange color to reflect the Dutch part of the heritage too.
All right.
Yeah.
There we go.
There's actually a city in Morocco called ZEDEDA. So,
Is there?
Wow. Yeah. It's spelled with a J, not a Z, but it's pronounced the same way.
You've got a city called OnLogic in Vermont there, Roland?
We don't, but I think it's about time.
It's about time.
Yeah.
So what's the future look like with Edge? I know it's a broad question, but I'm just curious. Like, we've been talking about Edge this whole time. What's the future look like?
Yeah, I think more and more AI, right? I mean, that's really that is primarily, I think, what you're going to see. More automated systems that are just more effectively, in a lot of the time, it's fault detection, just quality control, automated predictive maintenance, those kinds of things. And there's just so many areas where you can deploy that, right? So if you think about it, sort of it really is not so much about, there's really no limits if you think about it, right? So if you think about the factory floor where companies producing their widgets, whatever they are, there's still in most factories it's still very, very, very manual, right? And there's so many things where you can start automating those things and do all this quality control and predictive maintenance as part of that as well. I think that's where there's large amount of growth. We see in our customer base, factory automation, warehouse automation is big. Solar, wind farms, those kinds of things. A lot of those areas, energy in general, lots of opportunities there as well.
Saeed, what do you think the future is?
Yeah, no, I think just building on what Roland just said, I mean, we think it's AI, and we kind of call it also physical AI. So today it's a lot about the predictive analytics and processing data, but we're going to move them more into control as well, right? So controlling drones, robot arms, machines. And, if you think about like what's happening right now with the humanoid robots that Tesla and Figure and all these companies are building, that's actually a form of edge computing at the end. And there's going to be a lot more needed there. So I think, just to build on Roland, it's AI in many different shapes, regardless of generative, physical, predictive and AI, vision AI. And I think more and more organizations are going to try to figure out like, how can we build an architecture that supports all of these? If we're an enterprise and we manufacture, we do transportation, we have logistics, we have all these other pieces, how can we create a horizontal edge platform, both hardware and software, to support the business needs and continue this autonomous and automation everywhere?
And what also comes in there is security, right? So where historically there's this concept of OT and IT, right? Operations technology and information technology. Our systems are green grass certified, so they are similar kind of to ZEDEDA. They're ready to go. And as a matter of fact, it works with ZEDEDA as well. It's an ingredient into the whole chain as well. AWS is a partner of ours. We've been working with AWS for a long time. Saeed can probably explain a lot more about that.
Yeah, I mean, the cloud guys, obviously, they are trying to make edge happen, and they're providing tools to customers to run software on the edge to take data back to the cloud, because ultimately they care about like more and more cloud consumption. So Greengrass is a great example. We integrate with it. We integrate with alternatives of that from Azure and other companies, clouds. Yeah, and I think AWS has been a great partner. We work with AWS, work with Azure, work with all the cloud companies really, really well. And it's great to see sort of how the cloud guys are embracing the edge.
So what we've seen is that historically in a lot of factories and warehousing and stuff like that, you had the operations team kind of run their own little IT space, right? It's separate from the IT team who's running the office space and the cloud and things like that. That is no longer acceptable for a lot of CTOs, right? They need control over all these devices because you don't know anymore what's in your network, and that's a security risk. So what's happening now more and more is a real focus on security, right? Security from the start, right? Security from literally the supply chain, what components are in those computers, the firmware, the operating system, the application level, the connections between the cloud and the edge. All those things are super important as well. And I think that's, as much as there's the opportunities, there's also the risk side of things to keep in mind here.
Yeah, you don't want your coffee maker having like a web server.
and guess what? A lot of them do actually.
I know.
Yeah. Well, or worse, if you start deploying in environments where it's mission critical, like you're controlling, physical things, you could really create harm and damage. Like, I mean, the one of the reasons I talked earlier about this automotive customer, their biggest concern was software updates to the car getting compromised from the developer building a new version of some software that runs in the car and then getting that update into the car. Like there's many ways how you can deliver an update to a car. Mm-hmm. And they want to make sure that entire chain was extremely secure, because imagine somebody introducing some kind of a backdoor in a software update and millions of cars suddenly start driving around with, and somebody executes the backdoor. it could cause a lot of harm. So I think people are really worried that as we put more software everywhere and all those things are connected to the network, it just opens up a whole new slew of challenges that we didn't have before.
I know. I feel like such a dangerous person when I'm using the full self-driving Tesla. It's like at any moment we could get hacked.
Yes. Yeah, those are the challenges. And this is going to become more and more as we build more and more heavy machinery or big machines that are running AI and run lots of software. It could be in a factory. It could be in a chemical plant. It could be, like self-driving buses, trains. I mean, there's so much more happening right now where more and more is getting assisted and more is getting supported with AI. That security is top of mind for everybody.
Roland, have you guys done any like on-site hardware that's specifically designed for like inference?
Yeah, we do actually. We have just released a new edge server that is specifically for inference. We call it the Axial 300. Axial is our server line, our edge server line, and we have it can hold up to, well, depending on the type of graphics card, but it can hold 3 to 7 different graphics cards in there, and so you end up with this GPU acceleration that is pretty amazing. That combined with a Xeon server, chip, and then at that point you can really do some pretty great stuff. So we're doing more and more on that side, but it's really to kind of support our customers that do both sort of the both sides of that, right? They're really looking at sort of the AI in the field and sort of like the opportunity to really have the training and inferencing in sort of really high volume and high capacity going as well.
When let's take the GPU specifically that you're just talking about. Do the GPU manufacturers, do they make like hardened versions of their GPUs so that you as a manufacturer can take and put that into your existing casing? Or do they just sell the same thing everywhere? They don't make a hardened version and you have to figure out how to make the casing so good it protects it?
Yeah, there's a combination of hardened and life cycle. So the big problem in our industry and GPUs in general, right? Life cycles are pretty short. You might be able to buy a product, a certain GPU for a year or a year and a half, maybe 2 years if you're lucky. But frequently our customers are looking at a deployment over a number of years. So you want a product that's available for a larger period of time. So you end up with, we have specific long life GPUs that are available, but also GPUs that are meant for sort of more extreme temperatures and shock and vibration, those kinds of things. And then from there on, we can also do much more custom solutions that focus on more integrated. So it's not necessarily a PCIe card at that point. It becomes a GPU mounted onto a board through like MXM or other platforms.
And because the environments are so different, I mean, that's why you exist in the marketplace. There's not just like one solution you can just buy. Everyone has to go, here's the specific environment, the length of time I can maintain. Like you have to give all the details. And then you, with your experience and your teams, you figure out how to get them a solution. Is that right?
Yeah, every one of our systems is effectively custom, right? You can go on our website right now and order a system, and those are highly configurable to begin with. And a lot of customers do. But usually in the large deployments, it's even more specific to that particular customer, where whether it be the firmware that we load on there, the software we pre-image, but also frequently it's highly specific add-on cards or a completely custom design that we designed from scratch for that customer.
So you can put Said software on there if it's for that customer.
Said software will run on anything, but it is really all about. The beauty of what we're doing is we preload that software together, but also Said's team, ZEDEDA, will actually go and validate the hardware with their software and make sure it all works really well. So when you buy an OnLogic computer that is validated with ZEDEDA, it just is certified, it just works. And I think that's kind of the beauty of that. It's you don't have to worry about it. It just is ready to go.
And then do you handle like, I'll call it last mile. Do you handle like the actual install, like plugging it in up at the windmill, or is that all on the client?
We don't. We leave that to clients, and usually a lot of our clients have either a large install team themselves.
Yeah.
They have their own IT or people that actually manage those installs, or we work with systems integrators that do these kinds of things. We really focus more on the design and the hard stuff, the engineering. The install it should be relatively straightforward. I think that's also the other side of this, right? So the install is so easy because there's nothing to configure. You plug in the box and you turn it on, and then from there on, ZEDEDA takes it from there basically. And nobody needs to do, you don't need a technician to go and set it up. It all of a sudden, you plug it in and it shows up in the ZEDEDA platform. And from there on, whoever's managing that can actually install additional packages and updates and things like that.
So now no guys climbing the tower to enter in a Windows 95 key.
Correct. That's exactly what we're trying to do, right? We're trying to make it easy and very predictable and very manageable. So it's also from a let's just say for a second that great example. We just worked with a customer who has our computers in power plants, and they were doing a test with shock and vibration to make sure we can withstand earthquakes. The computer, everything is flying around. The computer was actually fine, but the mechanical pieces failed, and the computer flew on the ground and got physically. Computer was still working, but physically damaged on the outside. At that point, all you need to do is send a new computer, turn it back on, and it works. You don't need to actually provision it anymore. At that point, that's the beauty of that.
How did they test that?
There are very specific companies that do these
kids
tests.
Jumping on the bed. Yeah.
we as part of our systems, you got to go through all these certifications, right? You go to C and FCC and UL and those kinds of things. But then you go beyond that for there's these earthquake tests. So and this is really meant for, think about it. If you have a data center and you mount a server in a data center, you want to make sure that server can withstand, and the data center can withstand certain amounts of earthquakes in a situation like that. And then all those data centers actually are designed to withstand typically 9.5 G or so, because that's kind of the highest earthquake that's ever been recorded. And apparently our customer was testing this at something like 40 G, which is just a little more extreme than needed. So
wait, they're testing it at 40, and the highest recorded is 8 or 9?
8 or 9.5 is the highest recorded. Yeah.
All right. It's crazy. Look, I'm a pretty conservative person. I'd go 15 if I was being extra crazy. 40.
They did they explained to us they did a little bit of a calculation issue, and they went and went a little overboard in the test.
Look, what I'm saying, Roland, is I want to strap a hand grenade to it, and I want it to still work.
But here's the crazy part. In this case, right, at this very high, I think it was 40 G, it fell on the ground. And then there was a display and a number of other parts that actually broke. That was not our part, but the computer just worked. Did not fail.
There you go. So, I love it. They should just make the spaceship out of that.
They might just. Let's put it that way.
So closing thoughts, a couple rapid fire type questions. If you could give one tip and one tip only to the tech leaders listening for them to nail their edge deployment strategy, what would that tip be?
I would say get going. It's that simple, right? For one, I think it's important not to completely overthink the whole strategy. Start small and build it out over time. But if you don't get going, you're going to be left behind because it's everywhere.
Yeah, totally agree with Roland. And I think the other thing is, surround yourself with partners that have experience in this. Leverage the collective wisdom out there. We actually created, along with other folks, a community called Edge Monsters, which is an edge architects community where people can get together and exchange learnings from different verticals, different industries. And there's many more like these, but I think there's already a lot of edge happening. Learn from those folks that have already been a little bit longer working on it, avoid making the same mistakes, and surround yourself with partners that can help you connect you to other people.
And last question here, I'm gonna go Roland, then Saeed. Roland, if I gave you a time machine and you could go back in time to that first moment where you and Lisa spent that $80K on that vendor you weren't sure about to start this company, what's one piece of advice you'd give your past self?
Stick with it. That's it, right? There's so many moments where you kind of question, hey, is this really going anywhere? Is this the right approach? Are we doing the right thing? And you're going to make mistakes. It is what it is. But as long as you make more good decisions than bad decisions, you move ahead, right? That's how how I view it.
Saeed, same thing. Time machine. You get to go back to when you founded the company. What advice? And you're the founder, correct? I'm just assuming.
Founder.
That.
With a few other folks, we started it. I mean, I would say similar to Roland, worry less, accept mistakes will happen. And I think to Roland's point is you just gotta, there's no good or bad mistakes. There's making decisions and then making them work, right? And I think if you can operate with that, you get really far.
No hesitation. Just take the action, get it done. If it doesn't, once you make a decision, if it doesn't work, you can just make another decision.
That's right.
Yeah, I think Jeff Bezos has this thing called 1-door versus 2-door decisions. And we try to apply that a lot in ZEDEDA too, because you can overthink an earlier point about edge computing, get going. It's not a one-way door. I think it's similarly, like you just kind of have to understand, and especially one-way door decisions, just go, just make them and get going.
Well, this has been an absolute pleasure.
Great to meet you, Joel. And I really love your podcast. So I'm really looking forward to this episode coming out.
Yeah. And then tell Lisa I say hi, Roland.
I will absolutely do that. Yeah. She's right around the corner, I'm sure.
Thank you so much for listening. And if you found this episode useful, please share it with a friend or a colleague who you think would get value from it. And if you have topics that you'd like to hear discussed on the podcast, either add me on LinkedIn or send me an email, joel@moderncto.io. Every time I get an email or LinkedIn message, it absolutely makes my day and inspires me to keep going.